So finishing this, so OP divided by RS should equal NP divided by QS. And I can put the little divide symbol here. So OP goes to RS, OP goes to RS, NP goes to QS, NP first to last goes to first to last. So then I can set up my proportion here. So what is OP? OP is 24. And that's going to be 24 divided by RS, which is X. And that's going to equal NP, which is 8, divided by 17. So 24 over X is equal to 8 over 17. 24 over X is equal to 8 divided by 17. So then I have a proportion. I could cross multiply 24 times 17 on the right, 8 times X on the left, on the right. Sorry, 24 times 17 on the left. You could also write this backwards. I kind of like my X on the left. So I'm going to go 8 times X equals 24 times 17. I'm going to type in 24 times 17, see what that is. That's 408. So now 8X equals 408. Divide by 8, and you get 51. So find the length of RS. Let's see, RS, we would say RS is 51 inches. And I should put the little segment on top. So one thing that's kind of nice, so when would you use this in your real life? You could actually use similar figures to compute distances that are difficult to measure. So let's say you wanted to see how tall this tree was. What you could do, because you know how tall you are, and you know the angle is going to be the same. So if you know how tall you are, and you look at your shadow, you can also measure the tree's shadow to estimate how tall the tree is. And so looking at this, a tree casts a shadow that is 10 feet long. So you would say, okay, right here the shadow is 10 feet. Got that from here. The woman is 5 feet tall. And she casts a shadow that's 4 feet long. Two similar triangles are created. How tall is the tree? Well, you can set up your proportion. You could go 4 to the 10 is equal to 5 to the, and we'll call that X. So we could go 410 equals 5X, or we could go 5X equals 410, or we could even start from the big number to small, say 10 over 4 is equal to X over 5. Same thing. Let's do 4 to 10. We're going 4 to 10, and so now we're going to go 5. And I just realized that you don't measure trees diagonally for their height, so the height of the tree should be over here. So 4 over 10 equals 5 over X. You cross multiply, get 4X. 4 times X equals 5 times 10 is 50. Take your 50 divided by 4, and you get the tree is approximately 12.5 feet long. Looking at this woman's 5 feet, let's see, 5 feet comes to about right here. So yeah, I would expect that to be See, 10 feet would be about right here. So yeah, around 12 and a half, that makes sense to me, which is a very short tree. So a 6-foot tall man, so I'll measure him, he's 6 feet, put that next to him. He casts a shadow that's 4.5 feet long. A telephone pole casts a shadow, so this would be the shadow, that's 15.6 feet long. Two similar triangles are created. How tall is the telephone pole? So when I set up my proportion, I'm going to do height to height, length to length. So I'm going to say x over 6 is equal to 15.6 divided by 4.5. Cross multiply, and I'd get 4.5 times x is equal to 6 times 15.6, which is 93.6. Take 93.6 divided by 4.5, and I get 20, which is 20.8 feet. So how tall is that telephone pole? 20.8 feet. And I have never seen a telephone pole that's only 20 feet tall. I think they're usually much taller than that. So it's a bad example.